Alrighty.
Craig, I don't have to.
And we will begin with angle properties. Alright, on your piece of paper, I need you to draw a straight line. It does not matter how long it is. It does not matter if it is perfectly horizontal. Just draw a straight line. Okay? I also need for you to draw a triangle. It does not matter what shape or size, but make it big enough that your protractor will work with it. Okay? Everybody good? Okay. And then down below the straight line that you drew, oops, crap, I didn't mean to do that. Below the straight line that you drew, I need you to draw another straight line, but this one I need you to make an X with it. Two straight lines. It doesn't matter how big the X is. Everybody cool?
Yeah.
Okay. Starting with the straight line that you drew first. In the middle of that line, put a dot somewhere. Do not measure, just put the dot. Okay? Put a dot at each end and label those dots with the following capital letters: A, B, C. Everybody good? Okay, now put two dots above your line anywhere. Okay, I'm going to put mine there. I'm going to put my other one there. And label those dots D and E. Everybody cool? Connect DB and EB. So DB and EB. So everybody should be looking at something that looks like that right now. Right? And everybody's going to be different, isn't it? Everybody cool? Okay, now, this angle here is named. We name angles by points involved in the angle, okay? Now, if this was the only angle here, we could name him angle B, because B is the vertex, which is just in a fancy word for a corner. Okay? But is there more than one angle at B? Yeah, there's three. There's one, then there's this red one, then there's this blue one. Does everybody understand? So we can't just call it angle B, can we? Because there's even a fourth angle there, isn't there? The fourth angle that's there is this one all the way across the bottom. So angle B really has four angles there. So I can't call it angle B. So I have to change the name a little bit. So we have to name it with points on the angle. So the black angle is angle DBA or ABD. What's the thing that's the same in both? The corner, the vertex. That letter goes in the middle. And then you just follow the other letters. So DBA or ABD. Everybody cool? How many of you have done this before? Okay, good. So what's the middle angle? What's the red angle? DBE or EBD. And what's the blue angle? EBC or CBE. Everybody good? Everybody can read an angle, right? I don't have to worry about that anymore? Yeah? Okay. Now the next thing I need for you to do is measure these three angles. How many of you remember how to use a protractor? Okay. You take the 0 line, which is across the bottom. If you all have my protractor, it's the line that's right above Westcott. Right? And you put that 0 line on one of these two lines. On DB or AB. I'm going to use AB. Alright? So I put my triangle, my line right along there, and I put the circle, the dot in the middle, right on B. Does everybody understand that? So you can't see what I'm doing, but I got the open dot, the hole on the protractor right there. And I'm going to measure A, B, D. How do I measure it? I go up. Now you guys, the biggest mistake kids make when doing protractors is there's two lines of numbers here, right? Okay? And those two lines of numbers, one of them starts at 0 and one of them starts at 180, right? Where do we start counting? When we counted in grade 3, did we, with Mrs. Bagcrumble, did we go 180, 181, 182? No, we started at 0. So which of those two arcs of numbers am I going to use? The one that starts at 0 or the one that starts at 180? 0. The one that starts at 0. Kids say, I can't read this. I never can read it right. You're saying you don't know where we start counting? Where do we start counting? 0. So on your guys' protractors, that's the top half circle of numbers, isn't it? Right? So everybody measure your angle ABD. You know from Irish. Hey. Yep. Okay. Okay. Cool again. Thanks. Bye. Alright. So has everybody measured ABD? Okay. Mine is 50. Oops. 50 degrees. Okay? You all should have a different number. I mean, there's a chance you'll have 50. 1 in 300 or 1 in 180. But you all should have a different number, yeah? Now I'm going to measure the middle angle. So I got to lay my protractor down along DB, and I'm going to measure that. And it, for me, is 85 degrees. Yeah? And then, of course, obviously, I'm going to measure the third one. And it is 45 degrees. That's it? Now, of course, many of you have done this already, so you already know, but a lot of people just get this told to them. I like to prove it to you, so then when you can't do it properly later, I can say, how can you not do that? You were actually shown it. Because there's all these studies that say you guys do better when you actually do the work instead of get told. So I'm getting you to actually do the work. What does this prove? What happens when I take angle DBA plus angle DBE plus angle EBC? When I add those up, what did I get? Well, I get 50 plus 85 plus 45, which equals 180. All of you will also have very close to 180. Some of you will have 179, some of you will have 181. Why? Why will you not get perfectly 180? What are some possible reasons? Puneet? if you add poorly, right? You either didn't use your calculator or you hit a button wrong. Cool. What's some other reasons? You didn't measure correctly. You were a degree off. You didn't make your lines long enough and you're guessing. You follow me? Everybody good? All right. Now, the point I'm trying to make here is even if you don't do this experiment, what shape did I just draw in blue? It's a circle. That's why I had to lift the screen so I could hit shift and get a perfect circle. Right? That shape, half a circle is right here, isn't it? What's half a circle? 180 degrees. So if you have a straight line with angles on it, what does it have to add up to? 180 every single time. You don't even need to measure, do you? Okay? That is what is called supplementary. Supplementary angles add to 180. So as long as they're on a line, they're going to be 180. All right? If you know one of them, do you automatically know the other one?
Yeah.
How?
Minus.
Minus. So if this is x, what's this? If this angle here is x, an unknown amount, then what is this? 180 minus x. Cool? If you know two of them, do you know the third?
Yes.
If there's four and you know three of them, do you know the fourth? Yeah, everybody got it? Okay, easy peasy lemon squeezy. Now, triangles. You guys should already know this. What happens if I measure the angles of all these triangles? Do you know? Excellent, good. Everybody drew a triangle, yeah? Measure the three angles. I'm going to name this triangle A, B, C. We all have different triangles, don't we? Right? There's no chance we've drawn the exact same triangle, is there? No chance at all. So, let's measure the angles. You all know how to measure angles now. Please make sure that you are doing it correctly. I have 51 degrees. $52 degrees. And 78 degrees. When I add them up, A plus B plus C, what do I get? I get 181 degrees. What should I have gotten?
180.
180. Why? Why did I not get 180? Probably not so much that I measured wrong, but more likely because I got a screen between the line and my protractor. You picking up what I'm putting down? This is an acceptable margin of error because this is not a precision instrument, is it? Right? So what does that tell us? Everybody just measured three angles, yes? And when you add them up, what did you get? Around 180, yes? So what does that tell us? If it happens once in math, that's usually all we need to prove it, right? Except we just proved it 12 times, didn't we? So if it happens 12 times in math, it's really going to happen, isn't it? So that tells us that triangles always are supplementary. They always add to 180. So if you know two of the triangle angles, do you know the third automatically? Yes. Everybody good with that? Everybody good? Okay. Now, the X that you made, put a dot in the middle, Call that dot B. Got it? Then label around the outside as A, C, D, and E. Everybody cool? Okay. Measure one of those angles. It doesn't matter which one. Okay? Just measure one of them. Alright? I'm going to measure angle ABC. And I get angle ABC to be 109 degrees. Everybody cool? You guys will have something else. What do you got, Riley? You're measuring. You're actually doing it. What do you got?
111.
111. Terrific. Aiden, what do you got? 114. So everybody's done it, yeah? Now, that's the only angle we need to measure, and now we know the other three, don't we? Why? What is CBD? Some of you will need your calculator, that's fine. How are you going to find CBD? Your measurement from what? 180. So for me, CBD is going to be 71 degrees, isn't it? Cool? Now, you guys are smart kids. If CBD is 71, what do I have right here? Half circle, which adds up to 180. So what's angle EBD? 109. For me, what's it going to be for you? For you, who had 111, right? This is going to be what?
I don't know. I don't want to do it in my head.
Great, that's okay. But you understand how to do it, right? And then I can use what I already know over here. And then what happens over here? What does that make this? 71, which then tells us, hey, wait a minute, if angles are across from each other, what are they? They're the same. Without measuring. Everybody got it? Yeah? Okay, that's all you need today. So for all of angles and triangles. All of this is proven to you. You have done the work. Right? Okay, if you didn't write it down, no big deal, because you're about to write it down anyway in your notes. Okay? But I like to show it to you so you believe me. Because when I give the test on this, I still get kids trying to break out their calculators. I mean, their protractors. Even though you don't need to, ever, do you? Okay? So, flip up to the beginning of your notes, which has this review of everything. Okay. Now, obviously, we can't measure this angle because it's little, isn't it? Right? But we've done this experiment, haven't we? So, X is going to be 30 degrees. Z is going to be 65. What do you know X, Y, and Z have to be? You know they have to be 180. So do you now know what Y is? How? How do you know what Y is? Minus 65 and 30 from 180, right? Now, most of you are not comfortable doing that in your head, are you? But I will tell you, it's 85 degrees. Right? Now, what shape do they make? A semicircle. So, a semicircle, 180 degrees, yeah? So, angles on a line are supplementary. They add to 180. Cool? Point 1. Point 2, come to here. What does this symbol mean? right angle, which means what? 90 degrees, right? So because of that symbol, x plus y has to equal what? 90 degrees. Oops, the degree sign's already there. So if x and y is 90, and I know that x is 50, then how big's y? 40. Because you guys know it has to add to 90, right? Angles that add to 90 have their own name. Does anybody remember what it is? Complementary. Cool? Everybody good? Okay. This you also have proven already, haven't you? How many of those angles do you need to know all four? Two? One. If I tell you angle A is 85 degrees, do you now know all of them? What's B? I lie. What's C? 85. And what's B then? 95. And then what's D? 95. Okay, which angles are equal? A equals C and B equals D. Why? Angles that are vertically, what does vertically mean? Across. Angles that are vertically opposite are equal. Now somebody always says to me, well, Myers, A and C aren't vertical unless I move over to here, right? You understand what I'm saying? You guys get very confuzzled because for some reason paper becomes too heavy to lift and turn. Paneet.
If vertically times side and right, if you jump in sports and stuff, it's called vertical and go up and down.
I just explained to you, vertical does mean up and down, okay? But this construction is only, B and D are vertical only because of the way I'm holding the paper. Do you understand? If I turn my computer this way, what's the up and down ones? A and C now. You understand? That's why we call it vertically opposite, okay? Because I can turn the paper around, okay? On Earth, when I jump up in sports, I'm going up and down. Technically, I'm not, though, am I? Because if I'm on the equator, you would argue I'm jumping sideways. But I'm not, because up and down goes from the center straight out, right? Because there is no up and down on Earth or in space, right? We've invented that. Up means away from the center of the Earth. Cool? Everybody good? Vertically opposite angles are equal. That's all the stuff we've proven so far, correct? Now, in here, x is 65, y is 45. What is z? 70. Why? Has to add up to 180, except it's not going to be 70. Yeah, it is 70. Because they have to add up to 180. Triangles always add up to 180. Always. Okay? This is a special kind of triangle, which we're going to review of more in a minute. On my drawing, what do you notice about these bottom two angles? They're pretty darn close to the same, aren't they? If I measure this side, I get 7.2 centimeters. Then if I measure this side, I get 7.2 centimeters. No, because the bottom is different. These two sides are the same. The angles at the bottom are the same. These two sides are the same. What does that make the angles at the bottom? The same. Yeah? So, if I tell you that this is 85, do you know how big those two are? Why? Because they're the same, and the triangle has to add up to what? 180. So these two angles together have to be 95, right? It's 95 and 85 is 180. Since they're the same, what do I got to do to 95 there? Divide it by 2, which is 47.5, right? So these guys are both 47.5. And that's a special triangle, which we're going to talk about more in a minute. Two equal angles and sides. It's a mistake that a lot of math teachers make, I think is a mistake, is they always draw this isosceles triangle this way, with the same angles at the bottom. And then they say base angles are equal. What's wrong with that statement? Have any of you ever heard that? Have any of you heard a teacher talking about isosceles triangles and saying base angles are equal? No good. Because that's a mistake a lot of people make, because they want to draw an isosceles triangle up and down. Right? So you hear base angles are equal. Oh, these two are equal. Right? Until somebody does this and turns it. And now, oh my God. Well, this is the base because they're the bottom. Picking up what I'm putting down? Be careful. The paper's not too heavy to, turn. This one, now you guys are smart kids. If all these sides are the same, then all these angles must be the same, right? Right? So what is every angle there? Why? Because 60 times 3 is 180. Does it matter how big the triangle gets? No. I could draw a triangle from here to the moon to another spot in space. As long as all the sides are the same, the angle would be 60. You understand? That's why triangles are so useful, and that is why trig is so useful. You guys don't like trig. Some of your teachers taught you trig. How many of you guys have done some trigonometry? Right? Some schools will do it in grade 9, some won't. All right? The weird thing about triangles is even if you draw a little tiny one like this, the rules are the same when you extend that triangle to real life. That's why we can use blueprints and things. That's why this building, you can draw it on a piece of paper this big and then turn it into this. Because of these rules. Everybody understand? Okay. 3 equal sides and angles. Is everybody good with that? That's all background. Okay? Everybody's good? All right. Now, if you look in your notes packages, you will see that the next 2 pages, next 2-3 pages are work on this. Cool? I'm not going to get you to do it all in the room. Not right now. All right? We're going to move on to the triangle notes. Then I'm going to get you to go on these 3 pages, 4 pages. That'll be your work time today. Okay? You guys might have 5 pages. I can't remember. Everybody good? All right, so please turn to the triangle page. And you guys already know the first 2 here, yeah? We've already talked about them. What does an isosceles triangle look like? First of all, what do all triangles look like?
I have
3 sides. What's special about our friend Isosceles, named after the Greek guy who didn't discover it because the triangle was already there. The guy who figured this out. What does an isosceles have?
all equal sides.
Nope. 2 equal sides. So just draw a triangle. What do those symbols mean? Equal sides. So as soon as you see equal sides, the bottom 2 angles are equal. Anytime you see the same symbol, what does that mean? Equal. What if this changes? What if I draw a really long one? And I tell you these guys are equal. What does that tell us about the angles that are at the bottom of them? That they are equal. I'm going to call them X and X. What if I turn it upside down? Then which two angles are equal? These two. Let's call them y. Is everybody good with isosceles? As long as two sides are the same, the angles that are below them are the same. I say below, but you know what I mean, right? Everybody is good? Okay. Equilateral. Equa. Equal. Equivalent. Lateral. Side. You guys play football or rugby, passes have to be, in rugby, lateral or backwards. In football, if you throw a lateral, the guy you pass the ball to is beside you or behind you, then he can still throw a forward pass. Right? So equal sides. As soon as you draw an equal-sided triangle, what do you know? All sides are the same and all angles are 60. So if I gave you this, does that look like an equilateral triangle? No, but is it?
Yeah.
Why?
Because they're all the same.
Because I marked them all the same. It's just like it's a perspective thing, right? How many of you guys have gone and seen a real sport on TV? Well, you've gone and seen the real sport at the field, and then you've watched it on TV. What do the pictures on the field look like in reality? You know what I mean? Like when they put the Royal Bank symbol on the field or something. It's stretched and skewed, isn't it? When you watch it on TV, what does it look like? It looks perfect. Why? Because it's the way the camera is looking at it. Do you know what I'm saying? Right? Okay. It's especially prevalent in soccer and rugby and football because the field is so big and the stadiums are so big. Right? So this, remember, looks don't matter, information matters. So as soon as you see this, you know all of these are 60, don't you? Okay, everybody good with equilateral? All right. Scalene. Are any of those sides the same? How do you know? Because none of them are marked. Two ways you can know. Either they're not marked or we measure, right? Scalene, no equal sides. No equal angles. What's the only thing we know about this triangle? Yeah, the angles are supplementary. What does supplementary mean? They add to 180. Cool? Okay. And then the last triangle you need is a right triangle, which we've done a lot of work with, yeah? So what are stuff we know about a right triangle? Well, first of all, we know Pythagoras. I'm just going to write it down. You remember what Pythagoras is. We know that. But here's something that people often screw up. If I say this is 35, do you automatically know the third side, third angle? Yeah, because what is it? 55. Why? Right. This is 55 because 35 degrees, this was x, 35 degrees plus x had to equal 90, didn't it? Because I already had 90 here. A lot of you are going to make the mistake when you do this test of doing 180 minus 35 because you don't see a number here. But what's the number there? 90. Okay? The other mistake a lot of you are going to make is this. If I draw this line out here and I tell you this side is 90, The other side has to be 90 because it has to equal 180, doesn't it? But I won't put that symbol there. And you guys will be like, oh, I can't figure this out. I don't know. There's two empties. I don't know those angles. Picking up what I'm putting down? Okay, is everybody good? All right, so now let's put that into practice a little bit. We're going to do just this sheet together, and then I'm going to shut up and let you guys do a bit of those puzzle sheets. Okay? I'm not going to make you do all of them. I'm going to tell you the ones I want you specifically to make sure you get done. You with me? Okay, but first let's do this. 137 is something that we already know, right? So in geometry, we call that a given. So the 137 degrees is given. It's given to us. That's all we need, isn't it? What is angle Y? 137. Now, in math, we always have to prove it, right? Why do you guys know that 137 is Y? Because the other side is. Now, I gave you the proper name for that. You're not going to have that memorized. That's okay. You just wrote it down 2 minutes ago. But you know there's a reason, yeah? So when we're doing geometry, we always have to know our reasons. Grade 9, not so important. Further on, very important. Okay? So we're going to write our reason here. The reason is they are vertically opposite. Cool? Okay. So what does that make Z? Why? Right. Because of supplementary angles. Z had to equal 180 minus 137. Are we all cool? Yeah? Okay, now, what does this say? Given BC equals AC. That's giving us data for this triangle, isn't it? What does it mean to say BC equals AC? What am I allowed to do with this triangle? Where is BC? I'm going to make it red. Where is it? It's this line, yeah? And I'm going to make AC blue. Where's AC? Right here. So once we can identify them, I can say they're equal. So I can make this symbol, can't I? Once I see that symbol, does that give me information? What does it tell me? Two sides are the same. So the angles that they hit are what? Are equal. So angle X must be 75. Why? Because this is one of those special triangles, isn't it? Do you remember the name? Probably not. But it's an isosceles. Cool? So once I know this is 75, what can I write right here? 75. Does that now allow me to find Y? How? 75 and 75 is 150. Add 30 to get, well, not quite. You do 180 minus 150, right? So Y has to be 30. Why? Because triangles are supplementary. Oops. There shouldn't be an apostrophe there. Triangles are supplementary. Good? Everybody is good? You guys try this one. You've been given a lot of information, yeah? So what do I get to do as soon as I see given? What am I allowed to write in? Where is AE? Right here. A to E. Where is ED? Right here. What do we know about those two sides? So I can mark them, right? What does that automatically tell me? That V equals W, yeah? So if I know one of them, do I automatically know the other one? That's in my head. I know that. What else do we know? BDA is 90. So what do I get to do right here, BDA? I get to make it 90 degrees, don't I? Now, does that automatically give me X? How?
Add 90 and 15.
90 and 15 is 105, which means X has to be 75. X has to be 75 degrees. Why? Triangle or supplementary? Picking up what I'm putting down? Yeah? Okay, you got to figure out the other three. While I pee. I'm not going to tell you until I get back. Go.
Yes?
Oh, no.
I just hear you.
Yeah. Wi-Fi's not working. Kill us. Listen.
So what's going on with you? The principal came in yesterday, like, oh, we got ourselves to,
Janitor.
what? So are you cleaning our room now?
Yeah, A is 15.
What if you get y'all like my spine doing that?
Nice cracks, dude.
He's fucking dumb fuck.
What's the matter with you today?
What was that for?
What was your screenshot that? Watching? I know you read that, sir.
Got it yet? Did you do W or V or Z first? Does anybody have it? It's a better question. Nobody has it? What do you think V is?
I got 20.
20
I got 65. Wrong. I got 70.
for V?
Yes.
We got a 70. We got a 20. Do I have any other guesses for V? 35. So V, so far I've heard 25, 35. Did I hear 70? 70. Anything else? 37. How many of you tried to measure it with your protractor? Good, because there's no need. We have all the information we need. None of those are correct. So, I really like geometry because it's like a puzzle. Right? I gotta find V. I know that these two are the same, so I know V and W are the same, don't I? Everyone agree? What shape did I just make? Not a right angle triangle, just a regular triangle, an isosceles triangle, yeah? What's this angle right here? If this is 70, what's this? 110. How many degrees does this whole triangle get? I've got 110 right there. What do I know about these two? They're equal. So what must it be? 55. Whole triangle is 180. There's 110 of it. What's left over? 70. What do I got to do with that 70? Split it in half. So V is 35. No, you didn't. No, you didn't. Did I? Let's find out.
Oh, you're gonna play it back?
I don't know if I can go far enough back. Ah! Nah, I can't get it back.
Watch the video.
Maybe.
Yeah, just
If Bryn said 35, good for Bryn. She was right. Way to go, Bryn. Sorry about that.
want to stick.
Everybody good? So if V is 35, which mattered in the question, what does that make W? 35. Now, does anywhere in this question ask for W?
No.
No, but it is a new piece of information, isn't it? So we write it on the sheet, just in case it'll help us later. Will it help us later? Well, now I need Z, and that 35 is going to help us, isn't it? Because now how big is Z? What does that blue arc have to be? 180. There's 90 of it. There's 35 of it, which is 125, right? So what does that leave for Z? 55. So Z has to be 55. Why? Because of supplementary. Sub, because angles are on a line, correct? So now I know Z is 55, don't I? Right? So that's information, so I'm going to write it on there. Now I got to decide what kind of triangle DEC is. Well, it can't be a right angle triangle, can it? Because there's no 90s, so right angle's out. So can it be equilateral? No, because equilateral angles are all what? And they're 60. Are either of those 60?
Isosceles.
So he's out. So it has to be isosceles or scalene, right? If it's scalene, none of the angles are equal. If it's isosceles, two of the angles are equal, yeah? So I got to find this angle, don't I? How do I find it? $70 and 55 is 125. How do I find what y is? 125 minus 180. Other way around. 180 minus 125. To get what? Use your calculator if you need to. 55. Hey, two angles are the same, so what does that make it? Isosceles. Everybody picking up what I'm putting down? Okay. Your work time of the 4 puzzle sheets you have, I really want you to do, really the only one you need to do is 36, 35, and 36. These two. The definition decoder, and what do you get when? Okay? Now, listen to me closely, please, ladies and gentlemen. Do not use protractors. This is all done mathematically using these two drawings, okay? I'm going to show you how right now. Okay, is everybody good? Go to D36, the definition decoder. Angle 1 is 50. So that means angle 1 is 50 in this question only. If angle 1 is 50, what's angle 2 have to be? This side's 90, so this is 90. That's 50. Angle 2 must be 40. Understand? So now any 40 degrees get an H. Is that okay? Now in the next question, angle 3 is 120. So that changes. It's a new question. So this is done with. That info's gone. Everybody got it? Go over to the other side, and we'll do one over here. Angle 8 is 78. So angle 8 is 78. Angle 9 is 60. So what's angle 10? That makes a triangle. So angle 10 is 180 minus that, yeah? 180 minus 138 is 42. Cool? Everybody got it? So then any 42 would get an N. Okay? Don't measure. Use math. Okay, and those are the only two you got to do today. You only got to do 35 and 36. You don't have to care about the other ones. Everybody good? And you got 10 minutes with which to do so. 15 minutes with which to do so. Since it's only adding or subtracting and you have a calculator, this should not take very long, should it? And then on this side, it's the same thing. Okay? You just use math, add, subtract, find the answers. Alright? Go. Diddly-o. Then you're going to take your break, then you're going to come back, and we're going to do one section. Actually, I lied. We might be doing two sections. We're going to do tangent, radius, and we're going to do tangent chord. We're going to do two sections.